So in this lesson, you have construct a setup like this for the wire. It comes from the positive terminal and then pass through the first resistor and then the second resistor and then go back to the negative terminal. And what you extra add is the light bulbs connected in parallel to the first resistor, and then for the voltmeter is connected to the second resistor. And the build setup is look like this. And this time we use this LED instead of the light bulb, and then the first resistor is over there. And what we have to do is to connect our voltmeter. However, this time we use this microbit as a voltmeter. For P1, it actually equal to the positive side of the voltmeter, and this should be connected in parallel to our sample. And the sample will be clipped in between these two, and then you can see after connecting it directly, then the light bulbs light up somehow. Oh, and then the second thing is that you can use this to check the reading. And now, because they are not connected, it's an open circuit, so that the resistance will be very large. And you can see the reading. It may be 500 or something. It's a quite big value. But if I connect these two sides together, let's see. And because the crocodile clip, they are made by metal, so let's have a look. For the reading, it becomes 0. It's because its resistance is very low and it consumes low voltage at all. So that the reading, it will become 0. So let's try our 3 samples. The first one is 5 cm plus, times 1 cm aluminum foil as you cut. So let's clip it in between and then click the button again, and the reading is -1 or 2. You can see these are very small value, and now 0 is a little bit unstable. So -70, 17. So you can see it's a relatively quite low value. And let's change to another sample with graphite. Let's redraw. And we have totally 2 samples. One is thicker and the other one is thinner. Let's try the thinner one. And we can fold it like this so that the crocodile clip can be clipped on the top. And 5 cm apart. And then click the button again. 1014, a very big value. Just ignore the negative side, and it is a quite big value. It means that its resistance is very high, so that it will consume a large amount of voltage. Well, let's see. What if I change it to a thick graphite? This is the one with 5 cm plus 1 cm. Look like this. So I clip it onto the 2 sides, 5 cm apart. And let's check the reading. -949. Maybe these two are short circuit. Click it again. -970, quite a large number, but not as big as the thinner one, about 1000. It's just 900 and something. Oh, and let's record this reading and then turn it into maybe 1 cm apart with each other. Look like this by adjusting the distance, and then click button A again. Or it will become 2. And let's make it a little bit far away. The reading is 892 with this maybe 2 or 3 cm group apart. 2 cm apart. And try the 5 cm reading again. The reading is 900, 0 and 9. And what can you compare is that if they are connected to our aluminum foil, what's the reading? A very low reading. A graphite wire with 5 cm apart, a very large reading, around 1020 something. And then with this 5 cm graphite, the reading is 900 if you separate the two clips by 5 cm, and then very low if you clip it in 1 cm, and then when it's 2 or 3 cm it will become 800 something. And how can you analyze this data set? But of course, another evidence is about the brightness of the light bulb. But here, purely by the voltmeter or the microbit reading, I think you can see something